Welcome to the Deep Dive. This is where we take a stack of information, your articles, research, notes, and really dig in to find the key insights, those surprising facts, the aha moments, just to get you informed quickly. Today, we're embarking on a deep dive into the, fascinating world of AIGC 3D technology. That's AI-generated content for 3D, if you're new to the term. We've got a whole stack of sources here guiding us through, its development, where it is now, what the future might hold. Our mission is to understand not just what AIGC 3D is, but really the huge implications of how fast it's evolving, the hurdles it's clearing, and frankly, why it's shaping our digital future. And what seems immediately clear, right from the sources, is that AIGC 3D has hit a really critical threshold, wouldn't you say?
Well, absolutely. It's quite striking as our sources really highlight. We're looking at a field that's reached this um, crucial milestone, that fundamental shift from 0 to 1 in its ability to actually generate 3D content. And this isn't just, a technical thing. It fundamentally changes who can create 3D content. It democratizes it. Think rapid prototyping, quick concepts. It opens doors for industries that just couldn't afford traditional 3D pipelines before. But yeah, as the sources emphasize, there's still so much more to unpack here.
So this 0 to 1 moment,
Okay.
it sounds like a huge deal, but what does it actually mean for how we create 3D content right now? And what are the immediate challenges that pop up after such a big shift?
Well, it basically signifies that we can now generate a foundational, roughly acceptable 3D model from just a simple text prompt or maybe a single picture. Before, building a model that was often skilled work, took hours, maybe days. Now, we'd be talking seconds in some cases. It's a massive leap. However, and this is important, our sources really emphasize that most of these AI-generated 3D models, they still need quite a bit of optimization. And this kind of boils down to three key areas: the algorithms, the computing power needed, and, of course, the data.
Okay, yeah, let's unpack that. Algorithms first. When we talk about algorithms, what's the specific challenge in going from, say, a flat 2D image to a complete 3D object?
Right, so for computers, dimensions 2D, 3D, they're all just digital matrices, basically grids of numbers, right? The fundamental difference for 3D is you're adding that extra dimension of information. It means representing, manipulating complex spatial relationships. So this needs higher levels of training, more sophisticated algorithms. The core algorithmic challenge is really figuring out how to efficiently go from that 2D data, that flat picture, to a fully realized 3D view that holds up, that's consistent from all angles.
And computing power. I mean, I can only imagine how demanding 3D processing must be. Is that a major bottleneck here for AIGC 3D too?
Oh, it absolutely is, yes.
Yeah.
Well, we can now generate a mesh that's the digital surface made of polygons in just a few seconds in the fastest cases. Many existing algorithms can still take a very long time, even on powerful, like really high-end hardware. And that level of efficiency, well, it's just not enough for widespread use, certainly not for real-time interactive stuff.
That makes total sense. The sheer computational load is one thing, but what about the fuel for these algorithms, the data itself? We always hear how crucial data is for AI.
Yeah, and this raises a really important question. Where do we actually get enough high-quality 3D data? If you compare it to the massive, incredibly rich training sets available for 2D images, well, mature 3D data sets like ShapeNet or Objaverse, they only have maybe hundreds of thousands of data points. We just currently lack those vast amounts of diverse, high-quality 3D resources needed to train truly robust AIGC 3D models.
So, okay, given these hurdles, algorithms, power, data, where are we already seeing AIGC 3D starting to make an impact? And how's this changing things for industries like, say, design?
We're definitely beginning to see 3D creation applications mature quite rapidly.
Yeah.
Areas like VR, virtual reality, AR, augmented reality, also spatial creativity, visual creativity, environmental design. Imagine architects, instantly generating and tweaking building designs right there in VR, or game developers creating new assets super fast.
Right, and here's where it gets really interesting for a lot of people listening. With these tools now generating 3D models, should professional designers be worried? Is AI coming for their jobs, or is it more complex than that?
Well, our sources offer some reassurance, at least for now. The thing is, AI currently cannot create those highly detailed, super refined models that professional designers absolutely need. The goal for the design industry, generating truly workable 3D models. Models with smooth curves, operable surfaces, not just basic meshes, that's still pretty far off. The focus right now is getting clear mesh surfaces right. That's the critical first step. So it really underscores AI as this increasingly powerful tool, something that streamlines workflows, speeds things up, but doesn't replace human creativity in that detailed craft.
Okay, that's helpful context. Let's maybe dive into some of the foundational tech powering all this. Our sources mention Nerf and Gaussian quite a bit. Can you help us visualize how these basic methods actually work?
Yeah, these are really critical foundational pieces that let us reconstruct 3D environments from 2D inputs. So first, Nerf. That's neural radiance field. Think of it like filling a digital space with tiny invisible particles. Each one has a color, a transparency. Nerf takes a whole series of continuous 2D pictures of an object or maybe a scene. Then it sort of looks through this space with virtual rays using a neural network to figure out how all these particles combine to form a solid 3D object, viewable from different angles. You could say, take photos all around your living room, and Nerf could reconstruct that entire 3D space. Pretty high quality, pretty fast.
Wow, that sounds incredibly powerful for creating those continuous 3D scenes. But the sources also flag a major hurdle for some other models, like Stable Diffusion when it comes to 3D. What's the issue there?
Yeah, it's a really interesting contrast. While a diffusion model like Stable Diffusion is amazing for 2D images, right? A discontinuous model like that really struggles to maintain spatial consistency across different viewpoints when you try to generate continuous 3D interfaces. That's why you sometimes see that flickering or weird inconsistencies in AI animations made that way. It just can't consistently calculate the details for all viewpoints in a coherent 3D space.
Right, that flickering or inconsistency, that sounds like a killer problem for truly immersive 3D. So how did researchers start to tackle that specific challenge, getting 3D from 2D images consistently?
Okay, so that's where Zero123 comes in, published back in March 2023. It really tackled this head on. It trains a diffusion model, but it does it by learning the connections between lots of different objects seen from many angles. So you give it one image, specify an angle, and it can then generate pictures of that same object from other consistent angles.
Ah, okay. And 0123 sec, that sounds like it just pushed that even further.
Exactly. Zero123 plus mus, which came out in October 2023, refines this idea quite significantly. Imagine, like you're looking at a 3D Lego set. 0123 is like a master photographer. It takes 6 perfectly consistent pictures from fixed angles, front, back, left, right, top, bottom, all generated from just one single input image. And that series of consistent multi-view pictures, that becomes the ideal input for high-quality 3D reconstruction. Using methods like Nerf or Nudius or Gaussian, it solves that multi-view inconsistency problem beautifully.
You also mentioned Gaussian Splatting earlier as a real game changer. How does that stack up against something like Nerf, especially on speed and accuracy for the reconstruction part?
Right, connecting this back. Nerf is a neural network. It needs training, and that can make it relatively slow for real-time stuff. Gaussian Splatting, introduced August 2023. It's fundamentally different in how it reconstructs. It's based entirely on a mathematical representation of point these splats in space. It doesn't require that neural network training for the reconstruction itself. And this gives it 2 huge advantages for 3D reconstruction. It's incredibly accurate, and it is incredibly fast. It's like going from painting pixels by hand to having a magic wand that just renders photorealistic scenes instantly. The speed is honestly jaw-dropping.
Okay, wow. So now that we kind of grasped the foundational tech, let's talk practicalities. What actual tools have come out of these advances? What can people listening maybe try out themselves?
Yeah, the evolution of tools has been super rapid.
Yeah.
I saw Dream Fusion from Google back in September 2022. That was major. Describing a scene with words, getting a 3D model, showed the potential for text to 3D. Then Point E from OpenAI, December 2022. The goal there was generating 3D point cloud model from 2D images. Used a prompt, a trained model. It's maybe a bit rough, but a crucial proof of concept. A point cloud, just quickly, is like a digital cloud of XYZ data points mapping an object's surface.
Got it, like a digital scatter plot in 3D.
Exactly. Then building on that, Shape E, also OpenAI, May 2023. That was a big leap because it moved from point clouds to generating actual 3D meshes. Huge breakthrough at the time, even if maybe the results don't look quite as slick compared to today's very latest models.
Things move fast.
They really do. Then Dream Gaussian, September 2023, based on that open source Gaussian splatting tech. And yeah, it shows similar benefits. Faster, better details. You can create a basic model in like 30 seconds.
Yeah.
Dramatically faster. By November 2023, Wonder 3D popped up. It's open source, become quite mainstream actually. Its quality is really nicely balanced, results are impressive, especially how the bumps and textures match up. Our sources highly recommend trying Wonder 3D. Its balanced quality means it's often a good first tool to grab. Shows how open source is really pushing things forward. It works by generating normal maps first, then reconstructing the 3D model.
Interesting approach.
Yeah. Also November 2023, 12345 plus C. This model showed remarkable improvements in consistency and how smooth the mesh is. The code isn't public yet, but there's an online demo. You can prompt it with something complex like children's airplane toy, propeller on the nose, turbines under the wings. Highlights progress and quality.
Okay, so getting quite specific now.
Definitely. And finally, Stable Zero123, released by Stability AI in December 2023. Another open source model, an improvement on the original Zero123. Offers very high quality. It allows for those seamless multi-viewpoint 3D reconstructions from just a single input image. Super useful for 3D modeling, VR. It represents maybe a peak in single image to multi-view 3D right now.
So looking at this whole timeline, I mean, point E in late 2022 generating rough point clouds to today with Stable Zero123 and 12345 giving these refined, consistent meshes, it really feels like we have crossed a major threshold. What's the bigger picture takeaway here for AIGC 3D? Exactly, that 0 to 1 phase, largely resolved in 2022. We can now reliably generate a, let's say, a roughly acceptable 3D model. Now, is there still work to do? Yes, improving generation speed further, boosting model quality, handling more complex topology. Absolutely. But our sources really suggest these are more matters of time now. As the tech continues to advance, compute gets cheaper, data gets better, and the connections between these 3D generation technologies and other AI fields like language models, that's crucial too. It promises even more breakthroughs ahead. If we really connect this to the bigger picture, AIGC 3D tech, it's not just about making cool models, right? It's about fundamentally changing how we interact with and how we create for digital space. It's a really foundational shift in how we're going to build virtual worlds, experiences, even products.
It truly feels like it. We've seen how AIGC 3D has gone from, a theoretical possibility to actual tangible applications with just astonishing speed, clearing these huge hurdles as it goes.
Yeah.
The pace of development, from just typing a phrase to getting a recognizable 3D model in seconds, it's kind of mind-blowing. And for anyone, learning this tech, engaging with it, it just powerfully underscores how important continuous learning is.
Yeah.
And just exploring, being fearless with new tools. The pace of innovation in this specific field is simply breathtaking. Staying curious is definitely going to be key.
Absolutely. So here's maybe a final thought for you to mull over. If AI can now reliably create a foundational 3D model from just a single image, or even just a text prompt, what previously unimaginable real-world problems could we solve by transforming physical spaces, or maybe just concepts, into digital assets at lightning speed? What creative boundaries, what practical boundaries are going to be shattered next? We hope you feel better informed and maybe even more curious about all the possibilities. Thanks for diving deep with us today.